All right, welcome back. Now let's go over the definition of what we're talking about as slant asymptote. So it says let f of x be a rational function defined by f of x equal to this ratio of polynomials, the same thing that we saw before in the last video. So we have a polynomial on top and a polynomial on bottom, and also recognize that the degree of the top is n and the degree of the bottom is m. And so again, those are not necessarily the same degree. Okay, so 1 says if n is exactly 1 degree more than m. So in other words, if the degree of the top polynomial is exactly 1 more than the degree of the bottom, then you have a slant asymptote. The function will have a slant asymptote. Okay? 2, if the degree of the top is more than 1 degree higher. Okay? So in other words, if n is more than m plus 1. So again, let me repeat. If the degree of the numerator is more than 1 higher than the degree of the denominator, then what we could say is the end behavior of the function f of x resembles the end behavior of the power function y equals a sub n to the x sub n divided by b sub m times x to the mth power. So in other words, it behaves very much like the ratio of the leading terms. And you might recall from before when I talked about end behavior, remember the controlling behavior, the controlling part of the behavior is by the leading term, right? Because as x gets larger and larger and larger, well, the one that really controls the behavior is going to be the leading term here and the leading term here. So if we take the ratio of those two terms, we'll get a power function. And so if we know the behavior of that power function, then we know the end behavior of the graph of f of x. Okay, now also, one thing I do want to write, to find the equation, so if we want to find the equation that represents the slant or the nonlinear asymptote, what we're going to do is we're going to do division. We're going to divide, what we're going to do is we're going to divide the top and the bottom and find what that quotient function is. And whatever that quotient function is, that's going to be the equation of the asymptote. Whether it's a slant asymptote or whether we call, another term that we use, by the way, is oblique. An oblique asymptote. Okay? So it could be an oblique asymptote or a nonlinear. Okay? Asymptote. So slant or oblique. Okay? So nonlinear. So all we're going to do is just divide the numerator and the denominator and see what the quotient is. And the quotient will tell us the equation of the asymptote. All right, let's do some examples.